We're going to look at lesson 4.1, which is on writing and evaluating algebraic expressions. Before we do that, if you notice on page 184, topic overview, you can see what kind of lessons we're going to be looking at in this chapter. There are 8 lessons, and so we will be planning to split this up, looking at the first 4 lessons and then taking a test, and then the last 4 lessons and then taking a test on those. Page 187 talks about some vocabulary of things that we've talked about before. So if we look at these, number 1, when you blank an expression, you replace each variable with a given value. And finding the value means we would evaluate the expression. Number 2, to evaluate a plus 3 when a equals 7, you can blank 7 for a in the expression. And that would be substitute. We're substituting the 7 in place of the a. Number 3, the set of rules used to determine the order in which operations are performed is called the, and that would be the order of operations. Makes sense? Number 4, each part of an expression that is separated by a plus or minus sign is a or an. And that would be a term. Usually when we talk about terms, we actually, if it's subtraction, we can add the opposite in order to tell better what our term actually is. So generally we'll actually add the opposite and say that terms are separated by addition signs or plus signs. Number 5, a or an blank is a mathematical phrase that can contain numbers, variables, and operation symbols. And that would be an expression. Remember a difference, expression versus an equation. An expression doesn't have an equal sign, an equation does have an equal sign. Equation, equal sign. Number 6, when 2 numbers are multiplied to get a product, each number is called a or an. And that would be a factor. Numbers multiplied together are called factors. So these definitions here, it's important, even though we don't always necessarily, take a definition test when we do a math test every time. It's important that we know what these words mean because, for example, if the directions say evaluate this expression and you don't know what evaluate means, then you're not going to know what to do. So important that we always keep up with our vocabulary. Further down the page shows some things about order of operations and equivalent expressions, and you're welcome to do those. If you want to check those out of my book sometime, you can. We're not going to go through that for right now, though. Page 189 starts our lesson on writing and evaluating algebraic expressions, and what we're looking at on 189 we're actually going to skip over because this is what we're going to be learning about how to do in the lesson, so we can't really do it yet before we know how to do it. So if we look at example 1, an automatic dog feeder dispenses 2/5 of a cup of dog food each day. What expression can the dog owner use to determine the amount of food left in the feeder after D days? So again, 2/5 of a cup each day, and you can see they're starting out with 20 cups of food. So you can do a bar diagram here if you want. Looking at 20 cups total. Again, I didn't do bar diagrams going through school, so if this makes more sense to you, that's fine. It's not what I'm usually used to doing. But again, the 2/5 of a cup per day for D days, and you can see the arrow kind of showing how that's going to continue taking up more dog food. So ultimately what we're going to do is write an expression here to see how much food is remaining. So 20 cups is what we started with, and then we're taking out 2/5 of a cup per day times however many days. Okay, 2/5 of a cup times however many days. If we multiply, that's going to tell us how much dog food we've used, and then when we subtract that from 20, that's going to tell us how much food is left in the feeder. So if you look at the try it, Masumi started with $217 in her bank account. She deposits $25.50 each week and never withdraws any money. What expression can Masumi use to determine her account balance after W weeks? So deposits means that she's putting money into the bank. So she's starting out with $217 and then adding the $25.50 each week times however many weeks. So this would be an expression we could use to tell how much money she has in the bank. Example 2, the expression 999D plus 1299C can be used to find the total cost of D pounds of almonds and C pounds of cashews. How much does it cost to buy 1.5 pounds of almonds and 2.5 pounds of cashews? So they are giving us the expression, and this is just a matter of, like we talked about with our vocabulary, substituting and evaluating. So we're just going to replace for the almonds, replace the D with the 1.5, and replace for the cashews, replace the C with a 2.5, and then multiply. In this case, if you are using a calculator, 1.5 would be the same as 1 5/10 or 1.5. 2.5 would be the same as 2 5/10, 2.5, and then you can multiply, add those together. When you add those together, if it doesn't come out even, then we would just round that to the nearest cent, nearest hundredth. So that would be $47.46 would be our costs. So similar idea on the try it. Cost to rent a scooter is $5.50 per hour. Sorry, $15.50 per hour. And the cost to rent a watercraft is $22.80 per hour. Really, that information they're giving us, they are putting that into their expression here. On the expression, they've dropped the zeros off. We don't need a zero at the end of our decimal. If you want to keep those there, that's fine. It doesn't hurt anything. That's probably what I would do. So anyway, we're going to rent the scooter for 3.5 hours and the watercraft for 1 3/4 hours. So if we start with our expression, and then we can substitute into that. So scooters 3.5 would be the same as 3 5/10, and the watercraft is 1 3/4. 3/4 would be the same as 7/500. So 1 7/500, and then we can work that out. If you multiply and add those together, and you should get $94.15. Example 3, Malik and 2 friends earn M dollars in 1 week doing odd jobs. They split the earnings, so each friend gets 1/3 of the total earnings. Malik uses $32.50 of his earnings on lunch each week. Last week, the 3 friends earned $963. And how much money did Malik have left after paying for lunch? So if you look at this, we can write an expression, and ultimately he's starting out with one-third of the total earnings, so one-third of M. Another way you could write that would be M divided by 3, and then he's using $32.50 of that, so we're subtracting $32.50 from the earnings that he got. That would be our expression, and that's what we're starting with. It says write an expression. You've got to write that out first before you can substitute. Once we've done that, you can substitute in 963 in place of M. And again, if you did it this other way, very similar idea. So then you divide 963 by 3, which would be 321 minus 3250, and then you could see he would have, it'd be 288.5, which means $288.50 left after paying for lunch. Look at the try it. Amelia earns $8.74 per hour plus a gas allowance of $3.50 per day at her job. How much does Amelia's job pay in a day when she works 5.5 hours? Write an expression and evaluate for 5.5 hours. So again, they're asking us to write an expression first before we evaluate, so before we substitute that in. We are talking about just in one day here, so the gas allowance is $3.50 a day, so that's just going to be the $3.50. So basically we've got the her pay, her earnings, whatever you want to call it. So we could call it her hourly pay, and then her gas allowance. Those are the two components of what she's going to get paid. So the hourly pay, it's $8.74 per hour. And what's our variable here is going to be with the hours. So we could say let H represent the number of hours she works. Okay, we could put her name there, Amelia. I couldn't remember the spelling there, but anyway, that's called defining your variable, so that's a good idea to go ahead and say that first. And then her earnings, so it'd be $8.74 per hour. So $8.74 times however many hours she works, plus the gas allowance. Gas allowance is $3.50 per day, and we're just talking about for one day here, so that would be it. Would just be the $3.50. So that would be our expression. So that's actually our first answer on this problem. So once we get that, we should really go ahead and circle that, so we're saying, this is part of my answer to this problem. Then we're going to evaluate that for 5.5 hours. So 5.5 hours is the same as 5.5. And again, we can multiply 874 times 5.5 and then add the 350 on. And that should come out to be a total of $51.57. Okay, and even though, we've been, just to make things quicker to work out, we've been using calculators. Make sure you guys remember order of operations. Multiplication would come before the addition here. Be thinking about that, because if we don't remember and we're just not practicing at all, even thinking about order of operations, we're going to forget how that even works. Page 192, if we look at number 4, a tank containing 35 gallons of water is leaking at a rate of 1/4 a gallon per minute write an expression to determine the number of gallons left in the tank after m minutes. Okay, so we're starting out. Our starting point here would be the 35 gallons, and then the water is leaking out. So are we getting more water or are we getting less water? Well, it's leaking out, means we're going to have less water in there. So we're going to be subtracting from that 1/4 of a gallon per minute. So 1/4 of a gallon times however many minutes. So that would be our expression. And they're not telling us, evaluate for 20 minutes or anything like that. They're just saying write the expression. So once we've done that, we are done. Technically, another option, I prefer what we did here. Another option, 1/4 is the same as 25 hundredths. So this would be another way to write that. But again, preference would be keep fractions rather than changing the decimals. Because if you have like 1/3, if it was 1/3 of a gallon per minute that we were losing, 1/3 is 0.3 repeating as a decimal. So you don't want a repeating decimal in your problem. So easiest case for you guys is just keep it as a fraction, and then you don't have to worry about dealing with that. Number 5, they want us to write an algebraic expression Marshall can use to determine the total cost of buying a watermelon that weighs W pounds and some tomatoes that weigh T pounds. And how much will it cost to buy a watermelon that weighs 18.5 pounds and 5 pounds of tomatoes? So this one we've actually got 2 different variables here. They already defined them for us. Watermelon weighs W pounds, and then the tomatoes weigh T pounds. So our watermelon is going to be 18.5 pounds, and then we're going to get 5 pounds of tomatoes. But again, first it says write an algebraic expression that he can use. So we've got to write the expression first, and then we're going to substitute and evaluate that. So 2 parts here. We've got the watermelon and we've got the tomatoes. So the watermelon, it's 68 cents per pound. You can see over on the sign. So 68 cents a pound means we're going to have 68 cents times however many pounds our watermelon is. Okay, that's for our watermelon costs. You don't have to have the W in parentheses since we're multiplying. It's assumed parentheses, or it's assumed multiplication even if we don't have parentheses there. And then the tomatoes are $3.25 per pound. So that would be 325 times T. That would be for our tomatoes. Okay, and sometimes it's helpful when you guys do problems like this to just write kind of a general statement, watermelon costs plus tomato costs, and then kind of worry about what actually we're going to be doing to get that. Okay, so this would be our expression to start out with, and then we're going to circle that because that's part of our answer. And then we're going to substitute. So 18.5 pounds, that'd be the same as 18 5/10. And tomatoes would be 5 pounds. And on this problem, we would need to do both of the multiplication parts first and get those answers and then add those together. Anyway, cutting to the chase here, when you work that out and when you add those together, you would get $28.83 would be our total. All the problems the book's been giving us has been the fractions have always been like a half or 3/4 or something that comes out really nice as a decimal. If it doesn't come out nice as a decimal, remember what you could do. If it's a mixed number, you could change it to an improper fraction and then multiply straight across and then divide that out. That would probably be the easiest way to do that. You could change the decimal to a fraction also, but probably just as well to do what I just mentioned. Number 6, they're wanting us to find the value of this when x equals 4/10. So this is already set up for us. It's just a matter of substituting. This one we have now a fraction times a decimal. So 3/8, yes, we could change it to a decimal. It's going to be 375 thousandths, especially if you're doing that by hand. Not going to be a whole lot of fun maybe to work that out. Probably the easier way would be to just put the decimal. You could, one of two things. I just put the decimal over 1. Okay, 4/10 divided by 1 is still 4/10. Or your other option, you could write 4/10 as 4/10 as a fraction, and that you could reduce would be another option. Anyway, 3 times 4 is 12, so 3 times 4/10 would be 1 2/10. And then if you take 1 2/10 divided by 8, 8 goes into 12 one time, and 4 left. 8 goes into 45 times. That'd be 15 hundredths. And now we are back to subtracting decimals. So remember, subtracting decimals, we can add the opposite there. We have some positives and some negatives. So are they working together or against each other? They are working against each other. And so that means we're going to be subtracting them. Remember, when you add or subtract decimals, make sure your decimal points are lined up. And when you subtract that, you get 4 35 hundredths. Well, which one did we have more of? We had more negatives, so that would be negative 4 35 hundredths. If anybody did anything with fractions there, it's negative 4 35 over 100, which reduces to negative 4 7/20 would be another option for working that one out. 7 is the same idea. It's just that we have two different things to substitute, and then just remember that when you work that out, remember to do all the multiplication before you do the addition. And that one, actually, if you work it out, would end up being 4 if you are curious, and you may want to do that just to get some more practice on this here.